Good morning, students. In today's class, I will explain about another memory management technique which is widely used. In our last class, we learned the basic functions of memory management module of an operating system. The four functions of any memory management module of an operating system are keeping track of status of each location, allocation policy, that is deciding to whom the memory should be given, how much memory should be given, and in which area the particular job has to be loaded, all these things. Then allocate the memory or allocation. Finally, after the execution is over, the memory allocated should be reclaimed. So deallocation policy. Next, different management techniques for managing the main memory are single contiguous allocation, partition memory management, relocatable partition memory management, paging technique, demand paging, segmentation. In our last class, we studied about one earliest memory management technique called single contiguous allocation along with its merits and demerits. In today's class, we will be learning about another memory management technique called partition memory management, some of the salient features of partition memory management along with its merits and demerits. At the end of today's session, you will be in a position to understand how memory is managed in case of partition memory management technique. In what way a partition memory management technique is different from single contiguous memory management technique. What are its advantages and disadvantages? A partition memory management technique is also a simple memory management technique similar to single contiguous allocation. The difference between single contiguous allocation technique and partition memory management technique are, in case of single contiguous memory management, the entire memory is available for only one single program. That means it is suitable for uni-programming system, whereas a partition memory management technique is suitable for multi-programming technique. So that's the basic difference between single contiguous and partition technique. Single contiguous, uni-programming, and partition is multi-programming. Here also, the physical memory is divided into number of partition. In case of single contiguous memory technique also, the entire physical memory is divided into only two partitions. The first partition is for the operating system. All the remaining memory is allocated for single job. But here what happens is, all the available memory other than the area occupied by the operating system is divided into number of partition, and each partition is allocated to a different job. Since more than one job is there in the memory simultaneously, this technique we call it as a multi-programming technique. The size of the partition, that means how many partitions should be made and what is the size of each partition, depending on that one, we have two ways of partitioning. One is static partition, second one is dynamic partition. In the case of static partition, number of partitions are also fixed. The size of each partition is also fixed. In case of dynamic, you need not fix the size of each partition. At the same time, the number of partition to be made is also not decided well in advance. And when compared to single contiguous technique, a partition technique is much more sophisticated. So this is the memory representation of partition memory allocation technique. The first area is reserved for the operating system. Now the entire remaining memory is divided into, in this example, into how many partition? Three partition. First partition is for job 1, second partition is allocated to job 2, and the third partition is allocated to job 3. In each partition, we have two different parts. The area which is in white color is the area which is allocated and used by the job, and the area which is in maroon color is the area allocated but unused. So that means in partition memory management, in every partition, we have a job for some area of the memory and remaining memory is unused. Let us see how the four basic memory management functions are handled in this technique. Keeping track of status of each location. Here, instead of keeping track of status of each location, here we need to maintain we have to keep track of status of each partition. That means whether the partition is in free status or the partition is in allocated status. For this purpose, a register called, a table called partition status table is maintained that indicates, that stores this information. That is location of each partition. What is the starting address of each partition? What is the size of each partition? And what is the status of each partition? For example, 0 to 2000 byte is occupied by the operating system. And suppose the first partition starts at 2000 and it goes up to 5000 mean, then the partition status table contains the location of the partition. Location of the partition is 2000. Size will be 3000 and the status is free. Determining the allocation policy. So this is done by the job scheduler. The job scheduler decides which partition should be allocated to which job. Suppose there is a partition of size 2000 bytes, another partition of size 3000 bytes, and the job sizes are 1000 and 2500 mean, then for the first job, partition 1 is allocated. For the second job, partition 2 is allocated. That means deciding which partition should be allocated for each job is decided by the job scheduler. Allocation. A partition, once a job request comes mean, then the operating system searches all the partition, identify the most suitable partition for a particular job and allocate that partition to that particular job. After allocation, the status of that particular partition in the partition status table is updated. Before allocation, the status of that particular partition in the partition status table is free. Once a job is allocated to that particular partition mean and its status is changes to free allocated status. Last one is after the execution is over, the partition is released. That means whatever memory that was occupied by the job in that particular partition is released and the status of that partition is converted back into free status. These changes you have to make it in the partition status table. Now, so consider what are, let us study the advantages and disadvantages of partition memory management technique. The most important advantage of partition memory management technique when compared to single contiguous technique is it supports multi-programming. Here also not much costly hardware is required. Here also we need some protection mechanism for protecting one user program from another user program. At the same time, operating system should be protected from all the jobs. Whereas in the case of contiguous memory management, we need to protect operating system from only single job. Here, no job should access the operating system part. And the algorithm for memory allocation and also deallocation is simple and easy to implement here also. But it suffers from certain drawbacks. The first and the most important drawback of partition memory technique is fragmentation. Fragmentation means in every partition, some portion of the partition is used by the job. Remaining some portion of the partition will remain unused. That unused area will not be continuous. This unused area will be there in every partition. So every partition, we are leaving some area which is unused. So that's the biggest problem. If all these unused areas are together, then it will be useful. But here it will not be useful at all because some portion of the unused area is in one partition, some portion of the unused area is in some other partition, etc. They are not continuous. And here also, the job address space cannot exceed the size of the partition. Suppose for job 1, partition 1 is allocated and the size of the partition 1 is 3000 byte mean, and at any moment the user program or the job size should not exceed 3000 bytes. It should be within 3000 bytes. And it requires more memory than single contiguous allocation because here we need to have more than one job in the memory. Since we need to maintain more than one job in the memory, we need to maintain a table called partition status table. So partition status table itself takes some memory. So more the number of jobs, more entries will be there in the partition status table. Because if you are divided the memory into 3 partition mean, then the table has 3 rows. First row is for partition 1, second row is for partition 2, and third row is for partition 3. Instead of 3 partition, if you have 10 partition, if instead of 3 jobs, we have 10 jobs mean, the same table, now we have to make 10 rows. So that itself takes some memory mean, it requires more memory. Hardware support. Since this scheme supports multi-programming, it is necessary to maintain what? It is necessary to protect the operating system from all other programs. That means none of the user program should tamper the operating system. At the same time, one user program should not alter, one user program should not access the memory of other user program. And for this purpose, we need to maintain two registers. The first register is base register and the second register is limit register. A base register is a special register which stores the address of starting location of each partition, whereas the limit register stores the size of each partition. Suppose the partition number 2 starts at the address 5000 and it goes up to 9000 mean, then the from starting from 5000 to 9000. So starting address of the partition is 5000 and size is 4000 means it will go up to 9000. In that case, what happens is the base register is loaded with the address of starting location, that is 5000, and the limit register stores the size of the partition, that will be 4000. At each stage, we need to check, operating system need to check whether the memory address outside the partition is tried to access or not. That means any job is trying to access the memory which is beyond that, beyond its partition which is allocated to it. Suppose for job 1, partition 1 is allocated, which varies from 3000 to 5000 mean, then job 1 can access only the address starting from 3000 to 5000. It cannot access any address before 3000. It cannot access any address after 5000 also. Another advantage of use of base register is that job can be moved after it has started its execution. And third one is when a job is moved, suppose for job 1, partition 1 is allocated. Suppose the job moves to some other partition by the operating system in, the only thing we need to make changes is in the partition status table. Initially, the starting address of that partition and which job is allocated is there in the partition status table. Whenever a job is moved to some other partition, we need to alter the partition status table. How the partition is made? So we can make the partition of the memory in two different ways. One is static partition, other one is dynamic partition. A static partition is one. Here the memory is divided into number of partition before the job arrives. In case of dynamic partition, the memory is divided into partition depending on the size of the job after the job arrives. And in the case of static partition, the partition size, once you make the partition size mean you cannot alter. Suppose the first partition you made a size of 2000, second partition 2000, third partition 3000 mean, then throughout the job execution, the size of every partition remains fixed. Hence it's called as static partition. But the number of partition you can make, size of each partition is determined by the operating system, and operating system takes into consideration these factors. Suppose you have the memory, free memory starting from the address 2000 to 10,000. That means altogether you have 8000 bytes of memory free. And if you have 2 jobs, then how many partitions we can make? Only 2 partitions. If you have 3 jobs, you have to make it a 3 partition. If you have 5 jobs, then you have to make it 5 partitions. So the number of partition the operating system makes depends on degree of multi-programming. Degree of multi-programming indicate how many jobs are there. Available memory. Suppose the memory is available is only 2000 bytes. In that case, don't make 10 partition. Okay. And the average size of frequently processed job. The operating system takes into consideration what will be the average size of the job for making the partition. Operating system maintains a table which indicates which partitions are allocated and which partitions are free status. This table we call it as a generally partition status table. In case of static partition, the table is called as static partition status table. In case of dynamic partition, it is called as a dynamic partition status table. Initially, to start with, all the partitions are in free status. Once they are allocated for any job mean, then the status are converted into allocated. When a job arrives, new job arrives, what happens is, in the case of static partition, you already have made the partition. Whenever a new job arrives, then the operating system searches all the partition, identify the best partition for that job, and allocate the partition to that particular job. After a job is allocated in a particular partition, then the status of the partition is changes into allocated. Static allocation or static partition is appropriate when the size and frequency of jobs are well known. Let us consider how static partition is done. So assume that we have 4 partitions, 1, 2, 3, 4, 5. The first partition starts at 312K and the size is 8K means it will go from, the first partition will be from 312K to 320K. Second partition starts at 320K and the size is 32K, means 320K to 352K will be partition 2. And third partition starts at 352K, size is 32K, means then 352 to plus 32, 384K. And the fourth partition size is 120, means then 120 to 384 plus 120. It starts from 504 and the size is 520K, means it will go from 500K to 1024. To start with, the status of all the partitions are free status. Now, if the job arrives of size 1K, 9K, 9K, 33K, 120K, then which partition is allocated for which job we'll see. First job is size is 1K. Then which partition is suitable? We can allocate it for the first partition. The size of the first partition is 8K. So the size of the partition is 8K and the job size is only 1K. Remaining 7K is wasted. Second job, we can allocate the second partition whose size is 32K, but the job is size is only 9K, remaining 23 wasted. For the third job of size 9K, again you can allocate a partition of size 32K. There also 23K is wasted. For the fourth job, which is size is 33K, you can allocate a partition of size 120K. Remaining 87 is wasted. And for the last job of size 121K, you allocate a partition of size 520K. There 121K is used. Remaining 399K is wasted. So this is the biggest problem of fragment static partition, because already you know the size of every partition because partition is already done. After the job array, you have to allocate suitable partition for a particular job. Means the memory sometimes wasted only. Most of the time, the memory is wasted only. What is the alternative? Dynamic partition. In dynamic partition, the size of the partition is not fixed. After the job arrives, depending on the size of the job, we can make the partition dynamically. And here, the process size cannot be restricted since the partition size is decided according to the process size. Here, in the case of previous technique what happens here, you can't alter the size of any partition because all the partitions are of fixed size. Here, what happens is you are not making any partition of fixed size. After the job arrives, depending on the size of the job, you make the partitions of appropriate size. This technique we also call it as dynamic storage allocation, control storage allocation, or garbage collection. So when compared to static partition technique, dynamic partition results in better utilization of memory. The wastage will be less in case of dynamic partition when compared to static partition. Let us consider the same set of 5 jobs of size 1K, 9K, 9K, 33K, 121K. So here partitions are not made initially. Now what happens is, what is the size of first job? 1K. In that case, you can make a partition of maximum 2K because later stage the size of the job may increase. So don't allocate the don't make the partition exactly as the size of the job. Sorry. Second job is 9K. Then you can make a partition of size 10K. Third job size 9K. You can make a partition of size 9K. Fourth job is 33K. You can make a size of partition of size 40K. For the last job of size 121K, you can make a partition of size 130K. So here what happens here, for a job of size 1K, you are allocating a partition of size 2K, means maximum 1K is wasted. In the next partition also 1K is wasted. Next partition also 1K is wasted. In the last fourth partition, the job size is 33K, but the partition size is 40K, means maximum 7K is wasted. But when compared to static allocation, see, in the first partition itself 7K is wasted. Here it is 1K is wasted. Second partition 23K is wasted. Here 1K is wasted. So altogether the wastage will be very, very less in case of dynamic partition when compared to static partition. Let us discuss about the advantages and disadvantages of both static and dynamic partition. Static partition is easy to implement because you need not think about the size of the job. First only you make the partition. But here what happens is allocation and deallocation is complicated than contiguous allocation. And the degree of multi-programming is less in case of static allocation. It is high in case of dynamic partition. Memory wastage is more in case of static partition, and it is less in case of dynamic partition. So in today's class, we learned about another memory management technique which is suitable for multi-programming called partition memory management. Here, partition memory management, the whole memory is divided into a number of partition. Every partition is allocated for a different job. And partition, we can make it in two different ways. One is static, where the size will be fixed and the partitions are done before the job arrives. Second one is dynamic, where the size is arbitrary and depending on the job size, you make the partitions of appropriate size. First one has resulted in more wastage of memory, but it is simple. Second one is it is dynamic and it is more complicated. In the examination, the questions from this topic could be of something like this. Explain partition memory management in detail. Explain the different methods of partitioning technique. Discuss the merits and demerits of partition memory management. Illustrate with an example, static and dynamic partition. Let us take some simple multiple choice questions on today's concept. Biggest drawback of partition memory management. One of the biggest problem of partition memory management is fragmentation. Here what happens is, in every partition, some portions of the memory remain unutilized. So that cannot be used for any other purpose because that small area is not suitable for running any job. You saw that one, the space left over in every partition should be brought together, then you will get a huge chunk of memory, but that is not possible. The correct answer is B, fragmentation. Main advantage of partition technique is no fragmentation. No, fragmentation is there. Simple to implement. Okay, not exactly. Supports multi-program. That is the biggest advantage. If the partitions are made before the job arrives, it's called a static partition, fixed partition, dynamic partition, none of these. So before the job arrives, means it is static partition. The problem where the memory used is not contiguous, is called as, so you have memory, but the memory remains waste because it is not in continuous place. It's called as memory overlap, memory split, memory hole, fragmentation. The correct answer is fragmentation. In partition memory management technique, allocation policy is decided by the job scheduler. Okay, friends, hope you have enjoyed today's class. And the partition memory management technique is one of the most popular memory management technique for handling multi-programming concept. Okay, so with this, I will conclude today's session. For any of your doubts, clarification, you can contact me over that number or you can mail me. Okay, we'll wind up now. Thank you.